All right, so I think this is recording. Let's take a look at this word problem, this mixture problem. We'll do it by our two methods, the bucket method and the seesaw method is what we're calling them. And those aren't mathematical terms. Those are kind of descriptions that I've either seen through one video, that seesaw, and then the bucket. And I'm calling it bucket just because those are containers. The Johnsons have some friends drop in. They wish to serve sherry, but do not have enough to serve all the same kind. So they mix some which is 20% alcohol with some which is 14% alcohol, and the result is 5 quarts, which is 16% alcohol. How much of each kind of sherry did they have to mix? All right, so using the bucket method, I'm going to draw buckets. In this case, glasses of sherry. It is not a fixed size that we can always go and get a larger bucket in this type of a problem. All right. So we had some that was a 20% alcohol and some which was 14% alcohol. We combined those, we added those together in a container, and the result was 16. And that makes sense. That result, that final concentration, is always a number that's between my two concentrations. All right, so what we ended up with, the volume that we had, was 5 quarts. And it wants to know how much 20% did we use and how much 14% did we use. And you want to be a little bit careful. It's not going to do me any good to call one of these x and the other variable y. I guess I could do that, but then I have to mention to somebody that x plus y is 5. So I could set this up as two unknowns and two equations and solve it like that. But what we're really doing is just go ahead and saying, I'm going to let this variable be x, this volume be x, and since I know that the result is 5, the other one has to be 5 minus x. Because when you add these two volumes together, you have to get a total of 5. So I'm going to take the concentration times the volume here. I've got 20x. I've got 14 times the quantity 5 minus x. And I've got 16 times 5. Now, in most application problems, when you're dealing with percentages, you convert the percent to a decimal. But since all of these three terms are percentages, it doesn't matter whether I move the decimal place over 2 places and then turn around and multiply each term by 100, which would move the decimal point back. So let's step by step try to isolate the variable x. So here we want to apply the distributive property. And what is 14 times 5? Is that 70? I think so. Minus 14x. And 5 times 16, I think, is 80. All right, 20x, take away 14x is 6x. And take away 70 from each side, and I have 10. And divide by 6, and both of those are even numbers. So I have 5/3 of a quart of this 20% solution. And I know that together the two, I picked the wrong thing. Huh. What am I accidentally doing here? There we go. No. It somehow thinks that I want to do something with that when I don't want to do that. Well, I don't know. All right, I'm going to have to come over here. The 5 minus x, what is that? Well, I can rewrite 5 as 15 over 3. And 15 over 3 minus 5 over 3 is 10 over 3. And that's the volume that we have of the 14% solution. So those are our answers using the bucket method. Now, since I'm having difficulty here, I'm going to have to, yeah, okay, I've got that. I'm going to do the same problem again using the seesaw method. And since I was having difficulty, wouldn't let me shrink my previous work, I'm just going to get a new slate here. All right, so with the seesaw method, I want to identify the concentration that we're calling weak, identify our in-between concentration, and identify what we can call the strong concentration. So the weak concentration was the 14% alcohol solution. The in-between was our final mixture, 16%. And the strong was one of the two that we began with, was the 20%. So we had 5 quarts here. So we call, I can't remember which one that we called X. So I'm just going to call X the volume that I have in quarts of the weak solution, and the strong solution was 5 minus X because the total amount was 5 quarts. Now, this idea of the seesaw method is our balancing our fulcrum. We take the idea is with the seesaw was weight times distance, where the distance here is the difference between our concentrations. So let's do that. 16 minus 14 is 2. 20 minus 16 is 4. And now the weights we use as the volume. So we have weight times distance. We have 2x is equal to 4 times 5 minus x. And that's one equation and one unknown, and we can solve for x. So we've got 2x is equal to 20 minus 4x. And if we add 4x to each side, that gives us that 6x is equal to 20. If we divide by 6, we get 20 divided by 6, 20 over 6, but those are both even numbers, which reduces to 10 over 3. And that's the number of quarts that we have of our weak solution, which was our 14% alcohol solution. And our 5 minus x, the other amount of alcohol, I can rewrite 5 as 15 over 3, and 15 minus 10, 5. 5/3 was our 20%. So I may have had the x in the bucket method being the strong method. Like I say, that doesn't matter. What matters is that we get the same final answer. All right, so here's our answer. And unfortunately, I've already deleted the others, so I don't remember if that was the same, but I think it was. So, hey, I hope that helps, and I will talk to you later. Ask me any questions if you need to. Let me know if I've made any silly type of errors or arithmetic errors so I can edit the video and help other people. Talk to you later. Bye.